Hopefully everybody can see my screen. Please let me know otherwise. All right, let's get into this. All right. Hello,
Sorry,
everyone.
I can't see it yet. This is Negan from Blue Wave. Can anyone else not see your screen?
I cannot see it.
How about
now?
now?
I can.
Please.
There we
Okay,
go.
perfect. All
Yep,
right.
thank you.
Perfect. Thanks, everyone. All right, we'll get into it. So, hello, everyone. I'm Sam. I belong to West Monroe Partners. Happy to be here to help moderate, keep things moving along, keep the collaboration equitable across all the stakeholders that have showed up. Let me run through some of our material here. So, I'm going to do a very short introduction to tell you what we're going to achieve, what we're looking to achieve today, and a little bit of ground rules. So there's been a few workshops that have been performed to date last month, mostly focused on introducing the modernization plans, their forecasts, as well as the resultant infrastructure needs, including plans to address stakeholder and community needs. However, this additional workshop, technical in nature, was requested by the advisory committee. So we pulled together some utility experts. We took together some of the comments that were telegraphed by various stakeholders to create the objectives and agenda that I'm about to talk through. So in today's session, this remaining time, we want to discuss the current state of several distributed energy resource interconnections, as well as the infrastructure plans that are necessary to help them proliferate along with electrification. We are also going to have the utilities talk about their plans for monitoring and orchestrating DERs, namely through their DERMS platforms. We're going to discuss non-wire alternative frameworks and some areas in which they could be beneficial. And then perhaps most importantly, throughout this conversation, we have some dedicated Q&A where we're hoping to have some open dialogue and collaboration amongst the stakeholders and the utilities preparing these plans. Here's the agenda that you saw earlier. In a nutshell, it's twofold. The first one, Roman numeral 2, is largely about presenting the modernization plans at a high detail. We're going to have some Q&A following that session and a short break. And when we come back, then we get into the technical meat of these modernization plans. Once again, this agenda was informed by a number of questions and areas of topics for discussion that stakeholders had telegraphed. We'll launch into a 45-minute Q&A before adjourning. There are a number of utilities that are represented here across Eversource, National Grid, and Unitil. We tried to streamline the content that was prepared by them, so you'll see several of these members speaking throughout this presentation, which I'll help to coordinate, including time. That way we have plenty of time for Q&A from all of the stakeholders. I want to thank these utilities for preparing their material and being here today, as well as the TSRG for hosting us. And just a few quick ground rules, if you wouldn't mind. So we want this to be collaborative, so just a few rules. When we get to the Q&A sessions, please raise your hand if you have a question. Those of you that may not be familiar with Teams, if you look in the top ribbon, there is a raise hand feature. You press it once to raise your hand, you press it again to lower your hand. When you raise your hand, you'll be put into a queue and it's numbered, and that will be the queue from which I draw from. But when I do call upon you, can you please take a quick moment to tell us your name, your company or affiliation, and then your question. And in asking your question, please try to be as succinct as possible, because we're trying to get through as many stakeholder questions as we can. We want to make sure that everyone is heard. And then also, when asking your questions, please try to stay on theme here. Topics related to load forecasting, DER penetration, the DERMS platforms that are being contemplated, as well as non-wire alternatives. Now, of course, as you know, this is being recorded, so be considerate about any sensitive information that you may or may not share. And then with that, we're going to get right into the modernization plan discussion. I'm going to sequence a number of utility speakers here, so please bear with me. The first one, we're going to provide an overview, or rather, Elton will provide an overview of the modernization plans. Elton, if you'd be so kind.
Yeah, thanks, Sam, and good afternoon, everyone. So, as Sam said, Elton Prifty with National Grid. So I'll take you through a quick overview of the current system and what we have done so far with the current system, and then later on we're going to get into some of the discussions about what we are proposing as part of ESMP. So a quick overview of the current state of the system, some definitions and components that make up the current electric system. So we'll start with transmission lines, which are the lines that carry the that carry the power long distances and usually operate at the 69 kV or above. These lines are the ones that serve all the substations that we have throughout our service territory that step the voltage down to a lower voltage that is used for the distribution system, 15 kV or 4 kV as we refer to. And out of those substations are our distribution lines and feeders that you see mainly in the streets, whether it's overhead or underground, that go and serve all of our customers, and also interconnected distributed generation. So with that, in the generation space, like while the system in probably the last decade or so has changed. Previously, it was a one-way system where power flew from the generating stations through the transmission system into the distribution to serve the customers. In the day and age that we live on today, that system is a two-way flow, where there's power flowing from both the larger scale generation as well as the local distributed energy resources in the distribution system. So you'll see that on the chart there reflected on the right hand side. If we go to the next slide, please. This is a quick overview of the infrastructure by the numbers, so I won't get into any of the details, but each one of the utilities has represented their numbers on the distribution system in here, along with the number of customers, as well as a map of our service territory and how we divided or subdivided amongst all of us in here. Next slide. So I wanted to dive a little bit deeper on the substation component of the electric grid and the importance of the substation. So the substations, while they're the link between the transmission system, the distribution system, and eventually all of our customers, play a critical role in us providing or being able to provide service to our customers. And when we think about the need of the substations, the construction, whether it's building new, rebuilding, expanding existing substations, it takes time, and they're very costly investments, and there are certain constraints that are placed on us when it comes to the permitting, licensing, the design phases, the procurement of the material to build the substation. So in order for us to be able to meet the customer demands, whether it's from an economical development perspective or meet the demand of all the DER interconnections, building and expanding and having the right substation level and infrastructure in place to be ready for when those customer requests come to us is going to be critical in the success of our goal to meet the energy transition that the state has dictated for us. Can we go to the next slide? So an overview of the process of how we went about to identifying all the ESMP investments. So each one of the EDCs has a formal planning process that in general, it aligns with each other, while there's some nuances when you go from one company to the other. And that is mainly due to the history of how the systems were built and how we operate our systems, and also the constraints or the thresholds that we allow our system to be operated at. In general, we follow the same process that is laid out here on this graph on the right-hand side. But mainly we start with the forecasting, which presents the demand that is needed, and we apply our planning criteria to identify the thresholds and violations that could be caused from that forecast. And we put together the recommendations while we're doing all the engineering analysis. We work on the recommendations to come up with the solutions. In this space, there's the graph in here shows a number of different types of analysis that we as planners go through. But in general, this is the process that we have followed throughout the ESMP and all the investments that we have identified. And the investments from one utility to the other vary. Again, as I stated, It's based on the different needs that we have, the way that we have operated the system, and also the way that we have constructed our regulatory environment to when it comes to what we have already approved through the different rate cases, trackers, and the like. So next slide, I think.
Yep. Elton,
Turn it
thank
over
you
to
very
Kevin.
much.
Yep.
Exactly. Kevin, if you'd be so kind to talk about the targets, please.
Yes, thank you. So the goal of the SMPs is to try to support the clean energy goals that the Massachusetts State Legislature has laid out for us. All of the SMPs are in support of this pathway to decarbonization and are focused on the core investments, the gathering the information, modernizing the grid, providing those EV programs, interconnecting DERs, with the overall goal to make sure that the benefits are distributed in an equitable manner, and to have a sensitivity to those historically disadvantaged communities. Next slide. So the Clean Energy Climate Plan laid out different benchmarks for each of the sectors, the transportation sector, building sector, and power sector. And you'll see as we go through this that each of the utilities has taken an approach to scale the overall state benchmark down to our company sizes. I will point out that the state benchmark obviously covers the whole state. However, the 3 electric distribution companies do not cover the whole state. There's somewhere on the order of 40 to 41 municipals out there covering about 50 towns that are not represented by the plans that you would see today. All set, Sam.
Thank you, Kevin. And Kevin, correct me if I'm wrong, the power sector benchmarks are in gigawatts, right? The bottom row?
That is, yes, that is correct.
Wonderful, thank you. Okay, great. I'm gonna hand it over to Sophia. We've got this 3-minute segment to discuss the forecasting methodology of the utilities. Sophia, if you'd be so kind.
Yes, thank you, Sam. I'd like to talk about the overall forecasting methodology. And first, we must understand why we forecast, especially from a utility perspective. It's to ensure that we have sufficient system capacity and to really be able to serve our customers safely, reliably. We must be proactive about forecasting and ensuring that the customers are served before their needs are even realized, because infrastructure, as we all know, takes years to plan, site, and build, anywhere from 2 to 3 years for distribution circuit redesigns to decades plus for transmission. And the bigger the project, the more uncertainty and larger areas they cover. We must look in geographically specific and granular forecasts to be able to accurately reflect the reality. So, next slide, please. So here I've set out a timeline from today until 2050, which is the timeline for the state decarbonization and clean energy goals. I want to differentiate between a shorter term planning horizon and the long-term planning horizon. So in the near term, which is the driver for immediate capital infrastructure, the forecast leverage existing data sources and the latest market outlook, for example, projects in the queue. And we're really looking to identify site, design for, and construct for the near term. Now, on the long-term demand side, the forecast, especially for DERs, is to support the state and regulatory goals to align with the Massachusetts Clean Energy and Climate Plan. Next slide, please. In that aspect, even though we have a differentiation between long-term and short-term forecast, all the forecasts consider various scenarios and inputs. However, the 5 and 10-year forecast presents a single scenario for focus as they require immediate action by the electric distribution companies. Whereas the 2050 electric demand assessment will present sensitivities around different technologies and policies in the long term. So if you look at this graphic here on the left-hand side, we start with a bar representing the peak load forecast, which is described in detail in chapter 5, and what the components of that are made of: the current state of the distribution system, non-wires alternatives, and a capacity deficit. And combined and added on top of that is our 10-year reliability plan. So in order to forecast the long-term capacity need, we have to go even further to fill in the remaining capacity gap with proposed infrastructure to accommodate for electric vehicles, heating electrification, battery storage, and so on and so forth. And in that area is where the sensitivity and various scenarios and pathways come into play. And these eventually build to the bar on the right-hand side, which is the final 2050 electric demand assessment. Next slide, please. So across all the utilities, we share common methods to look at historic and existing system peaks. We look at historic SCADA readings on all of our large generation installations, any transfer corrections, large solar additions, or small solar generation at the peak, and conduct a 90-10 weather adjustment. 90-10 just means looking at the 90th percentile and making sure that loads are weather normalized to calculate the non-meter solar output. And at the end of that, we get a normalized station peak, and that is what is reported in our forecast. Now, in the next section, we're going to talk about how DG plays into that, how we make adjustments for additional components and various technologies. So to start, I'd like to talk to some of the assumptions specific to Eversource, but you'll see the same format addressed by Unitil and National Grid. So we talked a little bit about the 2050 state decarbonization goals. They're really to identify a path to decrease greenhouse gas emissions and reach net zero in the state. In that aspect, there's various pathways that are likely. And for Eversource, we've selected the all options pathway as our baseline. There's other ones like high electrification, phased pathways that will get incorporated into the sensitivity analysis. And when we scale that down on the Eversource level, we like to also not just look at the final numbers, but the breakdown by different vehicle class, by residential, commercial buildings, different types of technology, and so on and so forth. And in addition to that, you'll see different trends along the way from now to 2050. This is really a slide to look at 2050 from a very high level perspective. Next slide, please. So specifically for different DER components, you can see that we have various methods to forecast and to correct for individual technologies. So starting on the left side of this graphic, when we have the econometric trend load forecast, that's the 90-10, if you remember from 2 slides prior. And then we will incorporate energy efficiency and demand response, as well as a ER forecast, which includes existing installations and future forecasted projects. Within that, station peak will also look at load transfers, and a significant portion of future forecasted load comes from our large customers, comes from step loads. So we track every national strategic account and electrification efforts that are done in bulk. On top of that, for electric vehicles, we have a propensity model that looks at customer classifications and GPS mobility tracking to look at the growth and movement of vehicles as well as their potential charging patterns. And then finally, there's no way to not include the climate impacts if we're talking about a clean energy plan. So we have acquired a climate impact study with the probability of future heat waves that we incorporate into our forecast as well. And this all gets combined into what you will see in the ESMP report in terms of our forecasting methodology and results. So I'll pass it off to Kevin at Unitel.
Thank you, Sophia.
So as I had described earlier, this is how Unitel's plan shapes up in the attempt to meet those goals. Unitil is by far the smallest utility across the state, being about 1% of the size of Eversource and National Grid. So our plan, again, these are 2050 plans. I will caveat this with our forecast will be updated every year as we transition through to 2050 to account for the different adoption rates and technology changes that might affect how or the pace at which these technologies are adopted, and also to address any changes between now and then with the state's goals. Next slide. So I won't go through these next slides in detail, but I wanted to provide everyone with some additional look under the hood. So we break our load forecast down into what we call load adders and load reducers. And for this is the slide on the load adders. These are the types of added load that you would see included on top of the base load forecast, and some of those assumptions associated with each. And the next slide, Sam, are our load reducers. These are those items that are expected to reduce the forecast going forward. And again, I've provided the assumptions associated with those for you to view at some other time, but I didn't want to bog down the presentation in getting into the specifics of these. Next slide.
Thank you, Kevin. So this is National Grid's forecast. National Grid's forecast, DER forecast, align with the state climate targets. It's also worth to mention again that for the long run, the company does model multiple scenarios to account for uncertainties. Multiple state climate scenarios serve as the inputs to our forecast. So for PV, our base case model states all option scenario of 23 gigawatt. We take the company's share and account for amount of resource that can be considered as distributed resource, thus help reduce the load. Our forecast of close to 7 gigawatt align with this scenario. For energy storage, we look at both of the 3 gigawatt of option scenario and the 5.8 gigawatt from the phase scenario. Our base case lands in between those two scenarios, and our high case does exceed the 5.8 gigawatt scenario. So for electric vehicle, our base case models the California Clean Car and Clean Truck rules, which has been adopted by the state. The forecast meet the state target to reach over 90% of light duty electrification penetration and close to 90% of medium duty electrification, as well as about 40% of heavy duty vehicle electrification by 2050. For heat pump, we also meet the state target reaching over 68% of residential heating electrification and around 60% of commercial heating. So next slide, please. So here, this slide present a little bit more details on our geospatial analysis for the DG forecasting. We analyze land parcels for our ground-mounted PV analysis. We analyze customer demographic information for our rooftop propensity model, and then we analyze Q information for energy storage. The heat map on the bottom present our forecasted distribution of those DG resource by 2050. For ground-mounted PV, we project a significant growth in the central and western Massachusetts area. This also aligns with the currently what we are seeing in our queue. And for rooftop, the growth is spreading across the states, across our service territory. I'm sorry. Energy storage distribution is similar to like ground mount PV distribution. Thank you. Next slide.
Rain, thank you very much. So we have about 13 minutes before the Q&A, so we might take just a few extra minutes. But what I'd like to do is give 5 minutes for each utility to do an overview of their modernization plan. Elton, if we could start with you and try to limit ourselves to 5 minutes.
Yeah, absolutely. So before we get into what we're proposing as part of the ESMP, just a quick overview of what the National Grid system has been capable of handling to date. So I'm just going to focus more on the bottom part of this right-hand corner of the slide in here. And over the last decade plus, we've interconnected in the National Grid service territory over 2 gigawatts of DER in our system. And I know we're going to get into some of these details later on, but there's another 2 gigawatts pending in the queue for that we're studying and looking into interconnecting. When it comes to EV chargers, about 1,800 of them have already been deployed through the EV program, and we anticipate an additional 32,000 to be deployed as part of EV phase 3 program that goes through, I believe, end of 26, calendar year 26. Then on the heat pump space, I mean, while in total at the state level, there are 18,000 plus heat pumps already deployed. National Grid territory alone, it's over 10,000 of them. And looking over in the next few years, there is an incremental 45,000 throughout the state, with National Grid's portion of it being about 21,000 heat pumps being deployed through the customers. On the next slide, please, if we move over. So I know we discussed the forecast, and the graph on the left here shows what that forecast looks like over out to 2050. But the two maps in here, the first one down in the bottom that was also part of the previous slide, show all the substation locations and the loading of those substations as part of the 2023 analysis that we've done. When we've taken the forecast and applied it to the assets and figuring out how much of those assets are going to be loaded when we look out to 2035, you see the map on the right-hand side here with all the red dots indicating how much of the system is forecasted to be overloaded over the next 10 years. The other thing it's worth talking about in here, based on the forecast, sometime in the mid-2030s is where the system shifts from a summer peaking to a winter peaking system, and primarily that is driven from all the heat electrification that is anticipated and forecasted for the upcoming years. If we go to the next slide. So with that analysis, what have we done and what are we proposing as part of the SMP is in the next 5 years, we're looking at upgrading 13 existing substations with an additional 32 feeders. So this is based on the load forecast, what we've seen, where we could be getting the projects done and the time frame allowed when we take into consideration everything that goes in, whether it's the permitting, the design phases, the procurement of the long lead materials, and everything along those lines. In the second 5 years, which the timelines are already identified or provided to us through the legislation, we're looking at a large amount of infrastructure investment that we're going to do, right? When we think about 17 existing substations to be upgraded, 15 new ones, and 100 plus feeders on the distribution system that we're going to be building. Then we get into the 35 through 50 timeline, and again, there's more infrastructure that needs to be built throughout those years as well. The one thing that we're also doing in the meantime is looking into opportunities for NWAs and how could we be deferring infrastructure investments? How could we be utilizing any existing DER or future DERs to as part of the bridge to wires what we're referring to solutions in the cases where we won't be able to get the infrastructure built by the need date. How could we leverage the resources to get us to the construction already for load dates? So with all of this, and Sam, we can go to the next slide. When we think about what are the benefits that we're getting from all of this investments, right? So when we think about what the next 5 years, at least our plan in the SMP, we're looking at about 2.4 billion worth of investments in the distribution system and the upgrades that I mentioned earlier. When we sit back and look into it, is how much enabled capacities are going to be there. So with the projects that are planned to be in service in the first 5 years, we're looking at an incremental 1 gigawatt of enabled capacity, and that is both for load serving capabilities as well as hosting capacity, DER interconnections. And when we think about the 10-year plan, an incremental 3 gigawatts will be enabled for both load serving and DER interconnection capabilities. And I believe that's my last slide, and I think I turn it over to Laval.
That's perfect. Laval, if you'd be so kind, and try to keep it under 5 minutes, if possible.
That came up here. Thank you, Sam. I'll do my best. So Eversource is the largest utility in the New England region. We serve electricity, gas, and water customers in Connecticut, Massachusetts, and New Hampshire. Collectively in New Hampshire alone, in Massachusetts alone, we serve 1.5 million customers in 40 cities across 4 planning regions. These are shown on the map. Metro Boston, including Boston, Cambridge, Somerville, and Chelsea. Those are the major cities. The Metro West, about 35 towns and cities, including in the greater Boston area, Framingham, Newton, Waltham, Watertown, and so forth. In southeastern Massachusetts, all are parts of about 40 towns and cities, including the city of New Bedford and surrounding towns, all of Cape Cod, all of Martha's Vineyard, and western Massachusetts, consisting of about all are parts of 60 towns and cities, including the greater Springfield metropolitan area. Of these 1.5 million customers, fully about half of them, actually about 60% of those customers are in the Metro Boston region, and a significant portion of these customers are environmental justice customers. The distribution infrastructure to serve these customers is significant, and that's shown in the data to the right. I won't go through all of it, but of 172 substations, 101 are the bulk distribution stations that Elton described. We have about 20,000 miles of overhead and underground line, and almost 173,000 service transformers. The hosting capacity due to all this infrastructure is about 3.5 gigawatts. We have 1.8 gigawatts of DR installed and another 1.4 gigawatts in the queue. Numbers very similar to National Grid's. Our summer peak load is 6 gigawatts and our installed capacity 7.9 gigawatts. So that gives us a framework for where we are. At this point, we have enough capacity installed to meet the current demand. Next slide, please. This slide shows graphically our installed capacity walk. Right now, as I said, we have 7.9 gigawatts of installed capacity. Our 10-year plan, which is developed to meet imminent forecasted needs within the 10-year planning horizon, contemplates upgrading 12 existing substations and building another 14 substations before 2035, and adding another 6 substations after 2035, mostly in eastern Massachusetts. The capacity added by these investments is shown in the green bars, 3.4 gigawatts of added capacity in the first 10 years, and another 1.3 gigawatts thereafter. However, as the graph shows, the red bar indicates that there is still a 2.7 gigawatt deficiency statewide relevant to the demand we'll be seeing. And this demand, as Dr. Walker will discuss later in the forecasting section, is driven by the fact that we will switch to a winter peaking system sometime after 2035, and thereafter we expect our load to accelerate tremendously, and that's driving the capacity deficiency in 2035 and thereafter through 2050. Next slide, please. This slide basically lays out our 10-year infrastructure plan with the major capital projects. As I said, we are building 14 new substations and upgrading another 12. Of these substations, as you can see, there are 2 that are ongoing, a New Eagle substation in East Boston and a New Falmouth tap substation in southeastern Massachusetts. These are stations that are already in progress. In the first 5 years of our plan, we intend to build 4 new substations and upgrade 7 substations, including a new underground substation in the Cambridge area, our most expensive station that we have ever proposed and built. And we just finished going through the EFSB hearings for that station in East Cambridge. In the 10-year horizon, the first and the second 10 years, we'll add another 8 new substations and upgrade 1 new substations. So this is essentially the company's 10-year capital plan for load-driven needs. The company does understand that there is an imperative to plan for DER adoption and integration in the same manner that we plan for load. That is something I will address in a later session, so stay tuned, but just be cognizant of the fact that all of this infrastructure does increase the hosting capacity of our system. Next slide, please. In fact, we can, so just look at this slide, Sam. On this slide, it shows that most of the capacity deficiency is actually manifest in 2 areas. In the Metro West region and in the Southeast region, there's a 3.3 gigawatt deficiency relative to what's needed in 2050. We can close this gap by building 11 additional new substations in Metro West and another 10 to 11 new substations in the Southeast region. Obviously, this is way off into the future. It's very difficult to predict what we would need, but suffice it to say that additional solutions besides just building infrastructure would be needed to close that gap. Last slide, please. Section 7 of our ESMP provides a comprehensive view of our 10-year investment plans. The 10-year investment totals $12.1 billion, with expenditures relatively flat over the 10 years as shown in the chart on the bottom right. But worth noting is that less than $1 billion of this investment is identified as new capital expenses in the plan. Fully $11 billion, most of the plan was disclosed in our rate case and is driven by the demand in the 10-year period and not for the 2050 clean energy plan. So with that, I will pass it back to Kevin, I think. Thank you.
On to you, Kevin.
Okay, Sam, I noticed that we have a hand raised. I didn't know, John, if you had a question or a comment.
Oh. We were going to do a Q&A after, but John, if it's something that you need this very moment, of course we can.
No, I can wait to the Q&A. It's really just a point of clarification.
Thank you, sir. Kevin, if you'd be so kind.
Okay, thank you. So our plan as proposed right now separates our proposed projects into customer-facing projects and grid-facing projects. Our customer-facing projects are really focused around enabling the DERs that connect to the system to provide grid services. The first one is a study that we're proposing with all three utilities to develop the plan for these DERs to provide a grid service, but also have a compensation mechanism so those DERs could receive the benefit for providing that grid service. We also have a project for implementing FERC Order 2222, and this is really where we would develop the processes and the procedures and the software around those DERs or VPP situations to provide benefit to the system, and also EV charging and make ready. Our grid-facing projects are really a combination of extending our grid modernization plan of monitoring and control and optimization of the electric system, as well as providing some additional load capacity and hosting capacity for the couple substation projects we have, and also providing some targeted reliability and resiliency spending focused on targeted undergrounding and targeted spacer cable applications. Next slide. So within the ESMP, we've provided an overview of the spending, and that spending is really broken down between existing projects, meaning kind of our base capital spending projects, as well as previously approved projects, for which that includes grid modernization, the early years of our electric vehicle charging and make ready program, and some reliability and resiliency spending. Our proposed spending is close to $50 million over the first 5 years. The lion's share of that spending is focused on 2 substation projects, and the rest of that spending is spread out around those types of projects that I had identified on the previous page. Next slide.
That takes us out of your section. Thanks, Kevin. Appreciate that. Thanks, everyone, all the presenters, for staying on your time hacks. This is great. We're into our Q&A session, and it looks like we've collected a number of questions so far. I'd like to observe the order in which they came in, but I also want to iterate, please, if you have questions, raise your hand, because that way I can start queuing up what order they should be answered in. But as I observe the questions come in, I'm thinking, Russ, your 3-part question regarding cost allocation came in first. Would you be so kind as to iterate your question? But first, your name and affiliation.
Sure, my name is Russ Aney. I'm with Parallel Products Solar Energy. My question stems from when DPU 2075 effectively shut down due to the law that caused the creation of the Grid Mod Advisory Council. There was this notion that some of the cost allocation methods that were being piloted or suggested in DPU 2075 would be taken up by the electric sector modernization plans. I have not seen much clarity regarding how ideas such as the beneficiary pays principle might be carried over from the capital improvement projects or SIP projects that are group studies now, might be carried over for future group studies or system impact studies. And then similarly, how a common system modification fee might be used to pay for secondary network upgrades or secondary shared secondary service upgrades would be applied potentially for the simplified process interconnection customers. If any of the utilities could address how cost allocation is going to be treated, or how the success of 2075 is going to be built upon for future impact studies and group studies, I'd be grateful. Thank you.
Thank you, Russ. I would say any of the three utilities could chime in.
Excuse me, Sam, this is John Bonazzoli from Unitil. Russ, that's a good question, and my point of clarification that I had raised my hand for ties into this. One thing I just wanted to let people know, as Sophia had described, the EDCs forecast and plan the system-wide, they do their planning system-wide, which includes the substations. Separately from that, we forecast and plan the distribution system, which goes down to the customer. The distribution planning is not part of the scope of the ESMP. And for that reason, the proposed projects and costs that were listed do not include upgrades to the existing distribution circuits that may be required. For that reason, I want to make sure that especially the DER stakeholders don't expect that because we've done the system-wide planning on the ESMP, that impact studies are not will no longer be required. So I just wanted to make that an important clarification, that the ESMP is long-range planning down to the substation. It does not include distribution circuits. As far as the cost allocation, the ESMP legislation really didn't speak to that, but that's still kind of an open point.
John, is it that these modernization plans, at least the state legislation was written that it wasn't going to address this cost allocation, potential cost allocation changes? I'm trying to figure out if it's in scope for discussion here.
As I understand it, it did not speak to it in specifically, where
Gotcha.
2075 was specific to that. And that even 2075 didn't specify how it was going to be done. It was opening an investigation to that.
Gotcha. Thank you, John. If any utilities want to speak to, go ahead, Elton. I think you might have something.
Yeah, I just wanted to add to and build on top of what John was saying. So a little bit different on the national grid side. We are including some distribution line investments and scopes of work on our ESMP. But again, every application that comes in, whether it's load or DR, it will have location-specific scopes of work associated with it, to a point where we're still going to need those system impact studies to be performed to figure out what other implications that they will have on our system. So while we are including some scopes of work, it's not necessarily going to be site-specific. Therefore, there could be incremental scopes of work associated with any type of application depending on their location. When it comes to the SIP cost allocation methodology, the proposal we have in the SMP is that we continue on with that type of cost allocation while we're not proposing any SIPs in the ESMP from a national grid perspective. We're looking from the department to be approving at least the methodology that we can use for any of the group studies that are currently ongoing or in the process of getting completed.
Yep, and Sam, for Eversource, we have proposed 7 new SIPs in the ESMP using the same methodology as Elton said of the provisional program. We're assuming that will be approved going forward. And we also set up a construct in Chapter 9 of our ESMP about how we would approach closing that gap between where we are in terms of hosting capacity and where we need to be in 2050. And I plan to talk a little bit more about that in the second session. So Ross, it's a great question, but I can address it more specifically after I give my next presentation and talk about how we approach the SIP construct and the cost allocation methodology.
Looking forward to it, Lavelle. Thank you.
Okay, thank you.
Thank you, Elton and Lavelle. John, I wanted to check in with you because you had your hand raised still. Was there another clarification you were looking to state?
No, sorry, I'll take that down.
Oh, no, all good. I just didn't want to pass you up. I'm going to keep running down this list in the order in which it came in, but if others have questions, please feel free to raise your hand so I can queue you up. Russ, we'll stay on you. It looks like it's a clarification on forecasting and perhaps directed at Sophia in her forecasting section. Is that correct?
Yeah, so the input was 90-10 weather forecast, but at the very end, there was additional bump up required for, I don't know, I guess extraordinary climate change effects or something. I was curious as to why the normalized weather forecast didn't include those already, given that we know that there's expected or projected warming over the next few decades.
Sure, that's a great question, Russ. So the normalized 90-10 weather forecast looks at 30 years of historical weather, and that corrects for the historical weather conditions and extremes that we see, year to year at our stations. Whereas the climate forecast looks at future weather patterns, especially extreme events. So, like you said, we know that there is climate change impacts coming, but because there's different levels of GHG emissions based on the IPCC emission scenarios, we have those scenarios as additive to the forecast because there's not just one future-looking scenario versus the 30 years of historical actual weather.
Okay, so the 90-10 forecast didn't explore growth. Instead, it looked at probabilities and perhaps extremes on an average basis based on the data set of the last 30 years. And the climate forecast includes the growth in temperature or perhaps even extreme colds that we might expect to see over the next 40 years. Thank you.
Great. Thank you, Sophia. Russ, you've asked a number of questions, but if you don't mind, just to work in some other folks, I'm going to skip down to one of Claire's questions, and I'll come back up to yours. But others,
Sure.
please get in queue if you have a question. Claire, if you're still on the line, can you iterate your question below, starting with the 1 gigawatt and what time frame?
Sure. Can you hear me?
Yep, Claire.
Okay.
And your affiliation, please, if you'd be so kind.
So I'm with Greenfield Solar, a residential solar installer in Western Massachusetts. My question about the 1 gigawatt and what time frame, National Grid had a slide up that said that with the substation upgrades, they expected, I think, to anticipate 1 gigawatt of DER to be interconnected. I may have misunderstood the slide though, so that was what my question was. Was that 1 gigawatt a year or a decade or in what time frame?
Sure. So thanks for the question, Claire. So it's 1 gigawatt over the first 5-year period that we are going to be enabling. That doesn't mean that that's what's going to be interconnected. So with the investments that we are proposing, that takes us out to 2029. We are enabling 1 gigawatt of load serving capability, or as well as DER interconnection capabilities. And
So
that is
that's
across the state because the projects
Right.
are spread throughout the state.
right. So that is for all the new substations that are anticipated in that time frame.
Correct. All the upgrades to the substations, the additional distribution feeders do enable roughly about 1 gigawatt of capacity.
So to be honest, that's not very much. I don't see how the state's going to meet its 2030 climate goals with that small an increment growth for solar or any DER for that matter. So which leads into my second question then was how much DER can interconnect with each substation upgrade, which I kind of understand from the discussions since the presentations that the substation upgrades then are not intended to necessarily support increased interconnection. Is this correct that substation upgrades are merely to meet anticipated electrical demand?
It's both, but based on the forecast, the electric demand surpasses the DER interconnection. And then when it comes to how much each substation upgrade will enable from a DER interconnection capacity, it varies. It depends on what the substation currently serves from a load perspective, from a DER interconnection perspective. And then it also varies whether the DER is PV or solar battery interconnection, standalone batteries more specifically.
Well, I understand that your forecasting says that the demand will surpass the possibility for generation. But that's the forecasting is only as good as the numbers that go in. So if the state has set goals for 2030 and we actually meet those goals in terms of either solar or storage production, then that forecasting may be erroneous. And there may not actually need to be, if we can have enough distributed generation, those substation sites may actually be not suboptimal. And so I'm not clear as to how those substation sites are chosen. As a resident of Western Massachusetts, I see on the maps that basically nothing north of Springfield has planned. And there's a few substations in the Pittsfield, Berkshires area, but it's not clear to me whether the substations that are north of Springfield are vastly underutilized, and so we'll have plenty of space to add in demand.
And National Grid, of course.
Yeah, so our forecast, when we look at 2030 and the state goals, they do meet the state goals for 2030. The one thing that maybe I need to clarify is that the ESMP investments are on top of our normal investments that we're making, as well as some of the customer-specific scopes of work that are being scoped out currently as we speak through the group studies for all the DER interconnection. So there's a sort of a building block going on in here where we do have our core investment to maintain a safe and reliable system. There are all the customer requests associated that are on top of that with all the DER load customer requests. And then in addition to the first two groups of investments, we have proposed all the ESMP investments that work towards meeting the state goals for 2050.
Okay, that's very good. I'd like to hear from Eversource also, as they actually cover most of the areas I work in.
Yeah, sure. I can start, and then yes, I'll let my colleague jump in. So this actually, it'd be great if we had a dedicated conversation to this, because substation location is actually quite a complex undertaking, and I don't mean to tell you things that you know already, but if you look at our map, same as National Grid's map, a lot of our bulk distribution substations are located in areas where the load is dense. By the laws of physics, we have to site our stations near to the load to minimize the length of distribution feeders. And so you would see our stations clustered in that way. We try to look at the two main drivers for substation development, the load and the DER. And we look at both of these equally. In my purview, the distribution system planning team at Eversource has both a load team and a DER team, and both of these teams carry out the same exercises to determine how do we build infrastructure, how do we site substations for load and for DER. It just so happens in our ESMP that 12 of our substations are driven by load, but we're also building 3 new substations specifically for DER And those load substations do add a significant amount of hosting capacity for DER. And I have a slide later that shows that walk of hosting capacity of how we build on top of what we have now with the load-driven stations, with the SIP, the DER stations, and then what is that gap that you reference with respect to the 2050 goal? And then what do we need to do to close that gap? So I hope I can add some clarity later on, but I will let my colleague also chime in.
Yeah, and I think to add, and one thing that, and sorry, Gerhard, one thing that I forgot to mention in regards to like the investments that we have already proposed, and some of them are pending with the department right now, are the 2075B SIPs that do enable hosting capacity and our scopes of work associated with all the applications in those areas to interconnect DER.
It's got a red label on it.
Yeah, I just wanted to add in terms of what my colleague Mr. Freeman has said, and what Elton already echoed from the National Grid side. So just that there's no misunderstanding, the company's forecast, and that this applies to all companies, follow very strictly the proposed state objectives in terms of, Claire, we have a bit of echo from your side, thank you, in terms of the DER objectives, right? So that is directly baked into every one of those forecasts. So if the state hits its objectives, our forecasts are spot on. I just want to put that out there. And then in terms of the capacity build out, and we're looking at, Mr. Freeman's already touched on this. If we look at the maps, especially in Eversource's territory as well, a lot of our build out is clustered in the very urban areas due to the load growth. And then there is the SIP specific build out in the more rural areas to add solar capacity. Now, don't quote me right now. I'm looking up the number for total build out proposed in this, but if I'm looking at this here, we have this in the ESMP. We have SIPs pending in front of the DPU right now that add about 1 gigawatt of hosting capacity. There are more capital investment projects in the ESMP which add another 0.5 gigawatt of hosting capacity, and additional capital projects which add about 1 gigawatt additional hosting capacity. So all in, with SIPs in front of the DPU and what we have in the plan, we're adding 2.5 gigawatts of hosting capacity. And this is excluding downtown Boston. But it's going to build ground-mounted solar in downtown Boston. So those numbers are excluding downtown Boston, which, based on the state projection, gets us well into 2045 on the solar side.
Thank you, Gerard. Claire, sorry for muting you. If you have anything to say, please come off mute. Okay. Russ, you've been patient. I want to come back up to one of your questions, and then I want to start answering at least another question that's in queue. Russ, if you'd be so kind, I'm on the question about the interconnection pace has been slower, and you're curious if these utilities factor that into their current forecast.
Yep. So despite what Gerhard just said about we relied on the state data for DER growth, I also heard that the utilities looked at historical DER interconnection pace and used that to forecast at least the near-term DER growth. And I would note that in the last few years, the pace of DER growth has been controlled completely by the interconnection process, not a desire by the industry to interconnect more systems, both storage and distributed generation. In fact, I believe that both Eversource, believe all of the utilities have the largest interconnection queue backlogs that they have ever had at the moment. And it's the slow pace of interconnection processing that is causing fewer projects to interconnect these days at almost an historically low rate. I believe that Eversource's Smart Capacity Block 9 has been on Block 9 for almost 4 years, and I believe that National Grid's Block 10 is somewhere beyond 1.5 years, close to 2 years, that it's been stuck on that, largely due to the slow pace of processing or getting ISAs executed for larger projects, non-residential projects. And so I'm wondering how much that slow pace of the last few years skewed the perspective as to how much DER interconnections we'll see over the next few years. There's going to be a step up due to the CIP projects, but beyond that, what pace of growth do you see? And do you see that interconnection pace accelerating? And if that is the case, what investments are you making internally to enable the pace of interconnections to be processed faster? Thank you.
Russ, happy to chime in a bit on this, and very quickly. So yes, you're right. There's nothing wrong with the numbers you mentioned, and in terms of the backlog. So two things. For the short term, the existing queue does inform the short term. Right? Fast specifically, it informs where the solar is going and where not. Right? It tells us exactly where the industry is looking to develop, and that in turn informs where the SIPs are going. Right? The SIPs are informed on queue, and that's basically that information. In terms of the long-term forecast, and we're looking at solar, the way this is done is an annual build-out projection that is given by the state. And we're using in data based on available hosting capacity at that point of the system, at that point in time, and parcel information. We've had this discussion around the capabilities of the company to do the parcel analysis, to basically do an economic model of where the next solar development will go. And if a region is totally blocked out after the SIPs are built and the SIPs are fully subscribed, and the cost to interconnect skyrockets at that point, then that forecast focuses the build out in a different region of the system. So that's how that plays out. Agreed, right? This is subject to change. If the smart adders change, this will change. If land use restrictions change, this will change. If the SIPs don't get approved, that's a big problem, right? So we're building this based on today's knowledge and snap in time that we know, assuming the SIPs are being approved. The forecast assumes they're approved.
So Gerhard, or maybe if Shakir is on, can you explain what investments that Eversource is making to accelerate the study process for large DER projects? I would say that Eversource has extended the length of their studies more than anybody else by including dynamic studies, NPS CAD modeling. It's significantly extended the time it takes to complete studies. And I'm wondering if you all are making investments to accelerate the pace through which you can complete these studies.
So I'm not to shut this down, Russ, but now we're getting a bit off the ESMP. But
yeah, I wasn't clear
we have that project on the interconnection automation going, which you're aware of.
Yep.
And so that's the investment that Eversource is doing. That's some $3 million granted by the Grid Mod Fund. And we're in the middle of that project and procurement of the solutions. So that's happening.
Thank you. So I would say that for all of the utilities in National Grid, I'm very interested in any investments in modernization of your interconnection processing capabilities, which I think is a throttle or a critical constraint in your ability to achieve some of these goals.
Yeah, and we're going to touch on all of that on the next session, where we're going to talk about some of the technology enablement capabilities that we're looking into. So we would rather hold those questions or comments to after the next presentation.
I'll be back.
Perfect. Thank you, Russ, and thank you, team. I want to go back up to one new question. Doug Pope, if you're still on the line, would you be so kind as to state your affiliation and question in this last few minutes?
Yes, Doug Pope, Pope Energy. You referenced the instructions by the state. Are you using the 2020 2050 decarbonization roadmap completed by EEA that was completed December of 2020, or are you using the next generation roadmap of the legislation passed by the legislature in 2021? Because the decarbonization roadmap 2020 effectively puts a lot of DG installations, past 2035. And whereas this governor is intending to do 1.2 gigawatts a year by 2030. So which instructions are you using from the state?
I can speak to that on the Eversource side. So yes, you're right. There's two reports. The 2050 study that was first released in the 2021, and then the new one last summer. And our original analysis, we looked at the all options pathway in the 2021 study, and we have since compared the study projections to the mass CECP that was released. So they share a lot of the same base assumptions, and all of them include pathways to 2050. And so we've done comparisons and added those sensitivities to the additional scenarios for the long-term analysis, and we correct as we go to see which one is actually reflecting the current trend.
So
And
how does, go ahead, I'm sorry.
Just to add a quick comment on this, right? But regardless of which one you actually look at, the company's proposed capital investments, and Mr. Freeman can speak to this, are all happening in the next 10 years. So even if in a hypothetical scenario, you say all of the solar is coming right now and tomorrow based on the scenario, we can only build that fast. And we're already building what I just mentioned, 2.5 gigawatts pending approval by the DPU on the SIPs of capacity that get us to way past 2045 on both scenarios, right? So you can tweak those numbers on the scenarios, but in terms of what's being put on the system, right, it's going as fast as humanly possible, and that's what the company is proposing. And either one of those cases, it gets us past 2045 on the state projections.
So DOER about a year ago, in referencing the 2021 legislation, the next generation roadmap, stated that Massachusetts has to install between 27 and 35 gigawatts of solar by 2050. And the Healy administration, how are you responding to the Healy administration's intent to revise the SMART program to install 1.2 gigawatts a year, so that which is going to overwhelm your current I think 2 gigawatts that you're intending to do right now? How are you going to respond to that? Because it's happening in grid mod. You've got a grid mod proceeding that's happening right now, and they're asking you for these answers in that grid mod proceeding. So how are you going to respond to that?
We do have Jen Schilling on the line. If she's here, she can speak to what's happening in the grid mod topics. But I do have to point out, right, 1.2 is a split by this whole state. So probably half of that's going to go to our colleagues at National Grid. So it's 0.6 per utility. So still doesn't paint a rosy picture based on the numbers if you do the simple math, but it's a better picture. And then, I mean, from our perspective, right, we can only build so fast projects are approved. Right.
So if DPU,
that's something there's a limitation on what's possible.
So if your instructions were different from DPU to instruct you to accelerate your growth, you'd find a way to do that.
I'll let Mr. Freeman comment on how quickly we could, build 30 gigawatts worth of system capacity. But
look, the company has in our planning processes, as Elton showed, and all three of us are unified in how we plan. There are drivers that we respond to. And the overall drivers is customer demand, and policy directives, of course, are part of it. And then looking at the impact on our customers, particularly environmental justice and disadvantaged customers. We are reacting every day, all day long, to drivers and stimuli all across our system. If the state comes tomorrow and said, double your growth, I'm not promising you that's something that we can do, because as Sophia showed, it takes time to build capacity. But what it becomes is another driver for us to incorporate in our planning process and determine where and when and how we expand our system. That's all. It feeds into our process.
Thank you.
You're welcome.
Thank you, everyone, and thank you, Doug, for your question. We had a break scheduled for this moment, just a 5-minute break. Maybe let's still take that break because I assume some people have to use the restroom, and then we'll get back into this programming. Unless anybody's opposed, how about we meet back here at 45 after? Correction, 40 after. So we'll pick this up at 40 after. Maybe please use it to take a bathroom break or whatever you need to do. We'll get back to it in 5 minutes.
On their website, it's the analytics team at Austin.gov. I'm just gonna do that. And if I don't hear back in a week, I'll try again.
Someone on the call is not muted, just so we don't hear the
Hello, everyone. We'll be getting back to this in just a moment. Just give it another 30 seconds and then we'll launch into this to prompt people to come back. But thank you for making it back. All right, everyone, let's get back into it. So this next section is going to be about 40 minutes. We're going to let each of the three utilities do an overview of some of the relevant content that stakeholders had telegraphed. We're going to give each of them about 13 plus minutes to cover their respective sections, and then we'll do yet another Q&A for the remaining 45 minutes. But as I had mentioned before, as you have questions, please raise your hand so we can form a queue. But you can also put your question in the chat. That way some of us can start thinking through the questions, but please raise your hand. With that, we're going to start with National Grid. And Emily, if you'd be so kind, please kick us off.
All right. So I'm just going to spend a couple slides grounding us in the current state of interconnections as the foundation for our discussion around what we're proposing in the ESMP specific to DER and DG interconnections. Currently, National Grid has over 2 gigawatts of DG interconnected to date. Most of that is PV with a more modest amount of energy storage. If we look at what we currently have in queue, it's a comparable volume, over 2 gigawatts, again, sitting in queue, but the ratio has flipped. It's mostly energy storage currently. As we look to progressing what's in queue, our current interconnection policies and practices are largely limited by today's capabilities. So within the context of those interconnections, we have roughly 30 group study processes underway across all 6 subregions in our territory. The map in the lower right shows the distribution feeders that are currently in some stage of group study process, shown in color. You see it's the majority of our system currently. That's including 5 SIP proposals that we currently have awaiting DPU order that collectively will enable 342 megawatts. Our queue-based interconnection studies use historical information and our forecasts with a focus on mitigating system impacts from the interconnection of the DG in order to maintain safety and reliability. Within that context, we offer energy storage the choice of scheduling scheduled curtailment in order to avoid certain system modifications, but it's still the fundamental policy is that we need to accommodate DG operation as we ultimately memorialize it in ISAs, and that's the focus of the studies, is maintaining a safe and reliable system in that context. Next slide. As we look to our ESMP network infrastructure upgrades that Elton spoke about previously, as he said, those investments cumulatively enable 1 gigawatt of substation capacity by 2029 and another 3 gigawatts by 2034. And as we discussed earlier, that incremental substation capacity applies both for load serving, so EVs, electric heating and charging of batteries, as well as for hosting capacity, so PV, energy storage discharge, and other forms of DG. Fundamentally, though, right, we look at that 2029 is when that first big uptick in system capacity happens, and we still have 2 gigawatts sitting in our queue of active customer requests that we need to continue to progress. We are continuing to progress those. We've signaled in our ESMP that we intend to continue proposing the SIP cost allocation methodology for those group studies that are finalized following the DPU approval of the extension of the SIP methodology. And we also have flexible interconnection capabilities in development that my colleague Sammer will speak a little bit more about.
So DERMS means different things to each one of us. And I'm sure everybody's definition is probably close to being correct or close to being perfect. I wanted to talk to you a little bit about how we're thinking about it at National Grid. So for us, you're not just buying the specific software box. We are investing in specific capabilities, and I'll talk a little bit about them. We are going to deliver these capabilities in like stepstones so that I keep on getting better, giving you value quicker and faster. And that I also want to start integrating it into our ADMS, into AMI, so I can also create incremental value. When I'm thinking of DERMS and specifically to this user group, I'm thinking about it in two different ways. First was the points that I think Russ was making in clear. How do we get more out of the system? How do we reduce interconnection costs? How do we reduce interconnection time? How do we think or rethink about how we do hosting capacity? Is their way to rethink that? And also, like we said, we're all doing this because the people of Massachusetts have put in their clean energy goals and we're delivering their goals. That's the first one, interconnecting solar and storage on the system, interconnecting the system. The second one is, can DER actually provide a service to the system? And if that's the case, let's compensate the customers that are providing that service. Can you help us from a reliability perspective, help us avoid outages? And then can you help us restore the power quicker? I'll talk to you a little bit about my theory about why we think you can help us in both. Next. So flexible interconnections. Let me find ways to help you get on the system faster, at a cheaper cost. Now, while we're either waiting for the upgrades or until we kind of trigger the upgrades. We want to think about what am I going to need to do? And what I'm trying to do is I'm going to try to find different ways to offer you different flavors. For example, maybe you actually are an EV facility that cannot afford to be curtailed. Maybe you actually want the farm interconnection. Or maybe you're a school that is creating generation and load and you want to manage your generation and load in a way that you don't impact the system. Or maybe you are this facility that is participating in 3 different projects and programs and you think you can afford the curtailment or modification of your behavior. I'm going to have to do a lot of things to do that. I'm going to be able to communicate with you. I have to forecast you when you're going to be curtailed, when your behavior is going to change. I need to be able to dispatch you, make a decision on when to dispatch you. And then some of the stuff that Russ talked about is, am I going to be able to improve on my interconnection study perspective based on this flexibility? Can I automate some of this? And then can I show you where the capacity is coming from that flexibility? That's kind of the vision of flexible interconnection. Rethink hosting capacity. Next slide, Sam. So we're operating the same way your teams update. You start off with some features and then it keeps on getting better and better and better with MPAC. So the first part is stuff that actually we're going to send you a link to, which is the demonstration for energy storage and PV pilots for flexible interconnection. This is where the solar developers and specifically the ones that are in the pilot will help us understand a little bit more about what would work with them. Can we assume 0 capacity they're taking off the system if they operate correctly and then keep on jumping them off and operating them differently? What can we offer them and how can we offer them? That's going to go through the demo. Then we want to start offering it to more customers. We also see the possibility of this being needed for EV environment. We also want to make sure that we don't think or neglect the smaller size DERs or the DERs or customers like the households where you are adding generation and load and you're willing to manage that. And then the second thing is, what can I automate? What do I want to improve on from my interconnection studies? And how do I indicate that and articulate to you where the capacity that might come out of that flexibility comes from? And that's what we're trying to do with stepping stones and keep on getting better over time. Next one, Sam. This is just a link to the right now the demos that we are offering for PV and energy storage. I think this is where we get a lot of feedback. We start learning quickly and we can start scaling faster. So if you haven't or if you're not aware of this, please try to enroll. Next one, Sam. Next. So now we're thinking about grid service. So now you are actually helping the system. It's not about you, it's not about interconnecting you, reducing interconnection costs and time. It's about what type of services can you provide the system. We said we need to upgrade the system. Is there a place for your DR to help us with the load? You know, reduce any risk of outages or anything like that? Can your DR come in and help us recover after a fault? So it's not reliability now, it's resilience. I think there's a place for you. And how can I compensate? So we're already doing connected solutions. We're already trying to let you enroll in programs to resolve system peak. Can we do failure level things? I think if we invest in the forecasting correctly, we can do failure level things. Now, I need to have an enrollment registration process. I need to be able to predict the probability of your DR there. I need to be able to compensate you with a fund. I need to have a portal or a place for this customer experience to be done in. Billing and settlements, how we're going to all do that. So those are some of the investments we're doing in the grid mod and the SMP filing to help get that to you faster. Next one, Sam. And I think, so we can start easy, and that's what we're doing. Let's take the connected solutions and start thinking, can we focus on feature level problems? Then, can we open up a market where you actually bid your service and provide it at different times that are convenient to you? And can we use some of the tools that we're creating and add to them and be in compliance with FERC 2222 so you can even stack an additional value to that? Now, we're saying that we're going to invest in our settlements, we're going to invest in our payments, but the idea is let's start now, let's start quick, let's learn now, and let's keep on progressing and adding to it as we go. I think that was my last slide, Sam, but
Yep, perfect. We're going to hand it off to Josh for non-wire alternative. Josh, if you'd be so kind.
Yeah, absolutely. Thanks, Sam, and thanks, Samer. First, just a quick note on non-wires alternatives. I think one of the things that others have highlighted that's important to note is at the system level, the load reductions and shifts that we do have from our existing energy efficiency and demand response programs, they are incorporated into our forecasts, and therefore they're considered in our grid planning. So in other words, those demand side programs, they help the company build less than it otherwise would have already. Samer talked about that at a system level and how we're shifting towards looking at that for local needs. So level setting on NWAs, and then I just have a couple of slides on the key locations and how we will use those grid services to address NWAs. Starting on actually the right side first, I think people are probably more familiar with the definition we have here for a deferral NWA. Can we use a non-traditional solution to either reduce peak demand or increase peak supply in a given location? This is where we need sufficient advance ability to basically address that capacity need through the NWA that allows us to defer the planned investment that we'd be making. Bridge to wires is the same concept of bringing solutions to reduce peak demand or increase supply. The difference for us is these are needs that are more imminent, where we have a projected first year of overload on the system before we actually can feasibly build the infrastructure solution. So we need to really be able to deploy quickly to maintain reliability during that gap period between the year of overload and the year that we're able to build. And you'll see on the next slide that our real immediate focus is how do we address those needs. So these are the 18 locations that we are identifying as key bridge to wires locations in the ESMP. I'm not going to go through all the lists on the far right, but you can basically see these are the ones where we have a gap that I talked about on the previous slide of at least 5 years. So if you take an example like second row, new substation near Grafton, the first year of overload at that location is projected to be 2026. We don't project to be able to build the infrastructure solution to have that in service until 2034. That's more than a 5-year gap period. And we're looking to see what kinds of non-wire alternative, non-traditional solutions can we bring from a load generation flexibility perspective that can help bridge that gap. Just on the left, you can see quickly in the map, you've got sort of small here, but you can at least see location-wise. The pink dots, there's a few of those. Those are the ones that are projected in service in the 2025 through 2029 period. The blue ones are further out. That's the 6 to 10 years out. So basically 2030 to 2034, just to give you a sense of where those locations are and which ones have the biggest needs most imminently. Next slide. Okay, so kind of back to what Sam was saying about, so then what do we do to address those needs? We're really looking at sort of this preliminary two-pronged approach. I think the other utilities will talk a little bit about this as well. We're working out the details with them and Mass CEC for the first part of this, which is a grid service study. This is really where we think we need to work together to establish what are the levels of compensation for DERs, what's the value for providing those locational grid services like load flexibility. We want to work together to recommend what's the right mechanism. Again, Samer talked about sort of the connected solutions, expansion of program approaches versus markets. How do we do this most effectively to implement that grid services compensation framework? That's something that, again, working out the details, but hoping to do over the course of the next calendar year and into early 2025. The results of that study will then inform what we're proposing to use as a grid services compensation fund, which for National Grid is a proposed $40 million fund to basically compensate these third-party DERs, dispatchable DERs and flexible loads to address those needs. So that will be the fund, that would be the source of incentives for the locational demand response program incentives, as well as the local flexibility market procurements. And just a couple of notes, we envision this, especially on the flexibility market perspective, to be technology agnostic, so inclusive of basically we care about the need and how much of a value there is there and megawatts that we can bring to bear. We don't necessarily care as much about the specific technologies, though of course those will have different parameters to participate. And then participant-wise, we have developers. It can be aggregators of smaller assets. Those may be a little bit further out, and in some cases, large enough direct customers. And again, that compensation fund is something we propose over the duration of this ESMP. So we'd be tapping into those funds to provide incentives to help with the needs over the course of the 5 years, as shown on the slide. With that, I know we're a little bit over, Sam. I think, turn it over to the Eversource team.
Yep. Thank you, Emily, Samer, and Josh. We're going to hand it over to the Eversource team, and let's start with Lavelle, please.
Thank you, Sam. So the state of DER connection across the 4 planning regions is illustrated by these charts. I know there's a lot of numbers and a lot of colors, but really the top 4 charts show the installed DER in each region by DER type, and the bottom 4 chart shows the in-queue DER in each region, again by DER type. The overriding trends here are that the PV and PV plus storage and standalone storage is a significant portion of the overall DER in the install case, and even more so in the in-queue. And that is the green, the medium green, and the light green. And locationally speaking, about 2/3 of the installed DER is in southeastern Massachusetts and western Massachusetts, and over 80% of the in-queue DER is in these 2 regions alone. So that's really our hotbed of DER activity, borne out by these numbers. And 95% of the installed DER in these 2 regions is from PV, PV coupled with storage, and standalone BESS. So this just really illustrates the challenge that we are facing. Overall, there's 1.8 gigawatts online. I gave these numbers before, and about 1.8 gigawatts online, 1.4 in the queue. Most of these are in areas where there is already lots of DER, and so we're dealing with a congestion problem that needs to be ameliorated. Next slide, please. I'll skip this slide because Elton did a really good job explaining our planning process, so I won't belabor that anymore. In interest of time, let's go to the next slide, Sam. So this slide shows our a summary of the entire capital plan and major stations across our footprint, geographically, across the 4 regions. The company recognizes that the substations that we are building for loads, as I said before, do help with hosting capacity. The slide shows in gray the stations that are load driven, and in green, these are the stations that are involved in the initial SIPs filed with the DPU, maybe a year and a half ago. We had 6 SIPs that were filed. 1, it has been approved, the Marion Fairhaven SIP, and the other 5 are pending. And then in the ESMP, we filed 7 additional SIPs, and those are shown in the yellowish orange color. These 7 SIPs include a new substation, Whately Deerfield in Western Massachusetts. You can see near the top of the left side chart, and a new substation in Southeast Massachusetts called East Freetown. And the East Freetown station is really dependent on the Freetown SIP, which is shown below it. And if you recall, the Freetown SIP, it contemplated a transmission line from the Industrial Park substation to the Sonnet station, and that line would enable us to drop an East Freetown station along that route. And so we are anxiously waiting for the DPU to finish and publish its decision on those SIPs. So in total, as I mentioned before, there's 17 new stations, 14 driven by load and 3 driven by SIPs, and 26 substation upgrades, 12 driven by load and 14 driven by DER. Next slide, Sam. So on this slide, I'll spend a little bit of time to try to answer Russ's question. Not too much time because we want to get to Jennifer, but this slide it illustrates the hosting capacity due to the proposed investments. So as of 2023, the total DER hosting capacity is 3.5 gigawatts, and that's shown by the green horizontal line on the chart. There's currently 1.5 gigawatts of installed solar, and that's the dark shaded area on the bottom of the chart. And this is less than the hosting capacity, right, at a macro level, and that's a good thing. So we have sufficient hosting capacity for the solar that we've installed, obviously. Over the next 10 years, given the queue that I just mentioned and the econometric trends, solar generation is forecasted to increase to 2.9 gigawatts, and that's the light shaded blue area. Still less than the hosting capacity at a macro level. So we're good for the next 10 years. Now, the 10-year capital plan and the SIP solutions that I just mentioned, there were 17 new substations and 26 substation upgrades, will add another 3 gigawatts of hosting capacity. And that is shown by the yellow line that starts out to the left at 4.32 gigawatts, driven by stations that we are constructing now and will be in service by 2025. So in 2025, we'll see about a 4.32 gigawatt, a 1.3 gigawatt increase in hosting capacity, and it will top out at about 5.75 gigawatts in 2035 when our 10-year plan is fully implemented. The green bars on the chart show the state's solar roadmap through 2050. And so the thing to note here is that with the additional SIPs and the stations, we have enough hosting capacity to meet the 2040 goals. The 2050 goals do present a challenge in that there is a deficit of about 2.4 gigawatts relative to those goals. And in Section 9 of the ESMP, we have proposed a comprehensive integrated planning approach to identify high potential solar sites across the states and proactively build stations, basically following the SIP construct to ensure that we will be able to close that gap by 2050. But a lot of that depends on activities from the Department of Public Utilities. Last slide, please. So in summary, our plan increases grid capacity by 180% over the next decade. It adds 3.4 gigawatts of hosting of capacity for load. It allows the adoption of 2.5 million electric vehicles and 1 million heat pumps, and it enables 2.2 gigawatts of solar, exceeding the state's 2040 goals and reaching 72% of the 2050 goals. There's still work to be done, and working with developers, stakeholders, we hope that we can execute an aggressive program to close that gap and get us to where we want to be in 2050. Thank you, Sam. Jennifer?
Thank you, Lavelle. Yeah, on to you, Jennifer.
Great, thanks for having me. So in the interest of time, I will try and just build upon what Samer shared earlier with respect to the Eversource take on what we're calling, grid service, DER to provide grid services. So this is just a look at kind of our systems. These are the platforms that we're going to need to invest in, and we've asked for DPU support for in our
or will in our ESMP filing. So if you kind of follow the flow here, starting with the distribution management system is kind of the core control room technology that is going to identify a constraint on the system through a real-time load flow. The DERM system, which will be, which we're in the process of developing now and will be further developed with support of the ESMP. That's kind of the brain of knowing what's available and what can provide value to the grid. That then kicks off the dispatch function of being able to communicate either to behind the meter distributed energy resources or back through our SCADA system, large scale distributed energy resources, which can provide those grid services and make an impact on either voltage or power flows on the system, which would be reflected in the grid service in the field devices, which flows back to the distribution management system. So the point here is that the investments that we're proposing as a part of the ESMP to provide these systems are really platforms to being able to enable the use of distributed energy resources as grid assets. And so we know that we have to make these investments to be able to have the capability to execute on what we're going to talk about on the next slide. If you want to just look forward. Great, thanks. So in terms of the concept of virtual power plants, very similar concept. I'll just touch on this briefly in that, our control room needs to see what's going on the system in real time, and then, be able to communicate with any type of aggregated behind the meter or large scale front of the meter, which can respond. Our control room can see it and address the grid constraint. So this is how we call a virtual power plant, the terminology of being able to take all of these resources aggregated in a physical location at a specific point in time and be able to take those resources to bring them to bear to address some constraint on the distribution system. You want to flip to the next. So, I think Sammer did a nice job of talking about kind of the use cases and the whys. I'll just say that, there's a lot of different sources of value that distributed energy resources can bring to the system. And, some of that, the first one, which we called independent resource additions, shows up in the forecast. So energy efficiency, distributed generation, EV charging and discharging schedules, these things are happening in the grid and they're included in the forecast. And Sophia and Gerhard did a nice job talking about how they are taking these things into consideration in the forecast. But then you get to the need. And that's where, as we discussed earlier, the concept of bridge to wires becomes important. So as we're looking at the timeline of the need, to the extent that, we know there's a lot of construction and we're going to be challenged to be able to execute on it in the time frame that needs to be to address the needs on the system from electrification and other step loads. That concept of how can we use distributed energy resources to solve that need in the process of construction is important, and that's what we call bridge to wires. Then we have non-traditional approaches. So and Gerhard's going to talk about our non-wires alternative framework in a sec, but that's, if we can use batteries, we can use other technologies to address system need to get to the as-built grid. But really, in the end of the day, when what is the value proposition of DER as a grid service is going to be reflected on the impact of real-time load conditions, so weather, outages, whatever what's happening on the grid at a given point in time. That's when our operators need to be able to dispatch distributed energy resources. So that's where we're focused on trying to make sure that we have those platform investments to be able to take full advantage of DER in the real-time operations of the grid. Next slide. So we talked earlier, National Grid did, on the Grid Services Compensation Fund, so I won't expand on this more. It is an important component of our ESMP filing because we know that we need a mechanism and a funding source to be able to compensate distributed energy resources used as a grid asset. So we start with the study. We're hopeful that we can begin to actually execute on the program in 2025. So that assumes, you know, some of the platform investments that we talked about earlier are in place. We finished the study. We have a statewide framework to look at how much and what mechanism would we execute on the compensation. Obviously, there'll be requirements for participation, you know, communications and control, some contracted provisions for performance, and then, you know, but in the end of the day, compensation and dispatch frequency will vary based on local system need. I think we've probably come across many times, but all of this is, you know, all of this is local. We can have on average a certain amount of capacity, on average a certain amount of hosting capacity, but where the needs are is going to vary based on location, and that's what the Grid Services Compensation Fund is intended to address. So with that, I'm going to turn it over to Gerhard to get a little more specific on the NWA framework.
Excellent. Thank you, Jen. So as Jen mentioned, in those 3 steps, once we get to the point where we can't offset the need anymore, here through the Grid Compensation Fund or other measures, system planning steps in and we look at alternatives. So as mentioned already, and we can do this very quickly, is just the overview of we already account for the fact that there's solar development. We account for the existing solar sites, existing storage sites, and potential future charge management impacts or demand response impacts and energy efficiency programs in our forecast. So what we get out of the forecast, that net station forecast, is, as the name says already, net of all of those impacts. Next slide, please. So now we come to the need. Can you click once more? I think that's an animated slide. There might be something more coming. Might have taken the, yeah, exactly. So what happens when we have a need? Well, we have to develop a solution in system planning. So every solution, every project the company brings forward to get funding for and develops a solution, what we call a solution selection form, has to undergo a non-wires alternative screening process. For that purpose, the company has a non-wires alternative framework that looks at the option for the company to develop localized storage systems. For example, in the ESMP, there's Hyde Park Station, or other alternatives to target demand response, energy efficiency, localized spot generation, you name it, to defer the need of the traditional capital project. Those solutions that are considered here, and that's the difference between the Grid Compensation Fund and this solution, are utility-owned and operated solutions at this point. The process itself, we have the NWA framework. We have a continuous feedback loop into that framework. We do engage externally with stakeholders to continuously update our technology assumptions. We update financial assumptions in the framework if rate cases are passed. And I believe that framework is actually in the public domain. And if anybody's interested in reading that, we can happily provide the filing number where it's filed under. Next slide, please. This is just another quick view in terms of how this process works internally. It's just a little bit simplified, and what our timelines are should we identify such a solution. The whole purpose of this exercise for us is to be very effective and fast at screening. Believe it or not, there's a lot of capital projects that go through our funding approval process. So we've taken certain steps to identify the most likely projects, example being everything that's 3 million and above, or need horizon of 3 or more years out. And that's not asset condition related. But this allows us to basically vet every capital extension that we would do against the solution of deploying a targeted incremental above and beyond existing and forecasted. And that's the important part, solution that is not a traditional capital investment. Next slide, please. I do want to quickly go into a little bit, and we're not going to cover all that's in this framework, but a couple of key items that come up for us specifically if we're at this stage where the need is imminent and we need a solution at hand. The key item for us is reliability of the solution. We need any solution that we develop to perform at levels that is expected by our customers of the electric power system. So we are targeting, that's why also all these solutions at this point are then utility owned and operated. We have reliability models in the framework that look at, for example, in demand response programs availability. We look at N-1 considerations for non-wires alternative solutions, etc. We also look at the dispatch model. What's the capability of assets to dispatch? Taking demand response programs as another one. There are limitations, how often and how long those dispatches work. So all of that is built into this model, and the company develops a BCA, again, for every capital project that's 3 million and above, to look at a targeted non-wires alternative of the potential to defer that. Next slide. And that's it.
Thank you, Eversource team. Kevin, this next section is yours. I don't want to pinch you on time, but just maybe iterate that if any of your stuff is redundant and builds upon other utilities, maybe we can get to the parts that are specific to yours. Please, sir.
Sure, we can try to make up some time here. So the first slide that I have here is just to demonstrate the kind of the current status of interconnection on our system. We're just shy of 70 megawatts. To just give you a relative idea, the system itself is only about a 95 megawatt peak load system. So we have a really high penetration of DERs right now. We're not, we don't have any active studies, and we don't have any SIP proposals out there right now. Next slide. So we have 2 projects that have been identified within the first 5 years of the SMP. The first is an expansion of the Lunenburg substation. This is primarily driven by a new 3 megawatt load that's being served out of that station. That's proposed to be in service by peak load of 2026. And then we're also proposing a new South Lunenburg substation. This is really driven by the entire service territory down here is served by one interconnection into the transmission system. This new South Lunenburg substation would be another interconnect into the transmission system for us. And this would be proposed to be in service by peak load of 2030. What we've shown here is the locations of these. We've specifically tried to keep out of environmental justice communities as much as we can, but the circuitry that you see there is our volt bar optimization program that we are trying to align with the environmental justice communities within our service territory. So we're actively trying to keep those individuals in mind as we're trying to implement some of these new investments. Next slide. So stepping out to the next 10 years after the first 5 years, we have a few more projects, specifically capacity related. Primarily, they're focused on substation capacity additions, meaning larger transformers or second transformers, as well as some circuit capacity additions by splitting the loads. Next slide. And this goes out to the final 10 years of the plan. Again, couple new substations. Now you're seeing that some of these substations are working their way into the environmental justice communities. As Lavelle says, those tend to be the highest load centers within our territory as well. So physics tells us that it's most efficient to try to get that capacity closest to the load. But we would ultimately work to try to minimize those impacts. Next slide. So we've already, through our grid modernization plan, we've already are well on our way through the implementation of our ADMS system. We made the decision early in our grid modernization plan that the ADMS system would be kind of the central engine for a lot of our different platforms, such as OMS, SCADA, BVO, Flizzr, switch order management, and also DERMS. So the reason we wanted to do this is so that we could maintain one system, have one common network model, one system that our dispatchers are using and managing on a day-to-day basis. So in this ESMP, this is where we're proposing to roll out the DERMS portion of the ADMS platform. We're going to start that with a pilot of a couple of our company-owned facilities that we have, an energy storage facility and a solar facility, to try to kind of work the kinks out and make sure that the system is designed and operates the way we expect. But ultimately, the DERMS will also support our FERC Order 2222 initiatives and our enabling DER to provide grid service initiatives. Next slide. So our non-wires alternative framework, I'll start by saying that the forecast that we provide already accounts for the coincident generation of each of the DERs that we're forecasting. So those are already reducing the loads on our system, and from a planning standpoint, we're already taking credit for that. Our non-wires is above and beyond that. So these are location-specific areas where a traditional solution that's above greater than $500,000 for us and has a required construction start date, more than 3 years, but kind of within that 3 to 5 year in the future. That's where we would initiate a non-wires alternative. And the way that we tend to do that is we tend to release requests for information, requests for proposals, and then use those proposals to evaluate the reliability, availability, and capacity characteristics of the proposed non-wires alternative to the traditional solution. And that's all done really on an hour-to-hour basis. We want to make sure that as we're planning the system to address the peaks on our system, that the non-wires alternative will be available and reliable at the time that we need it, so that we can rely on it. And really the criteria for non-wires is really kind of wide open in our minds. You can see the list that I provided there. And ultimately, as we go forward and as future technologies come about, or existing technologies either become more reliable or more cost effective or more available, those would then be evaluated as such. Next slide. So we talked about this a little bit earlier. And you've heard a bit about this, but this is, we're kind of walking hand in hand with the other EDCs on the study and the compensation fund for enabling DERs as grid service. So I won't get into that anymore. Next slide. And I talked a little bit about for order 2222 a little bit earlier. You know, the goals are trying to remove barriers for the DERs to interconnect and to participate in the markets. So we need to make sure that we can interconnect these, you know, reliably and safely to our system, and also enable participation of these DERs within the wholesale market. Next slide. Next slide. All right.
Thank you.
Tried to get us through it quickly.
No, you folks did wonderfully. We've got about 35 minutes to go through some questions. So there's some questions that have been queued up in the chat, and maybe I'll go top to bottom. And where there's a ton of questions, maybe I'll skip around just to make sure there's some good representation. But I would like to start with, and I apologize if I butcher this name, is it Rin Mai? Are you still
Yeah,
on
it's
the
just
phone?
MK. MK is good. Thanks.
Oh, MK, your first question is about distinguishing between DER export and load hosting.
Yeah, that was for Emily.
And could you state your affiliation? I'm so sorry, Emily, to cut you off. But
Sorry,
MK,
yeah,
your
this is
affiliation?
MK from New Leaf Energy.
Beautiful. Sorry, Emily, go ahead.
Sure. So the capacity that we've stated is the increase in transformer rated capacity through each of the investments. So that capacity applies both to load and to hosting capacity. So it applies as an incremental ratings increase in both directions. And it's not something that we would allocate right to either load or DER, right? If we had 1 megawatt of EV charging show up on that transformer, that doesn't take 1 megawatt away from a DG export customer. Although a battery that needed to charge from the system, you know, would need incremental charging capacity. So it depends on the type of DER, but for our plan, we did not allocate the incremental capacity to different use cases.
MK, is that helpful?
Yeah, and I think it would be different, I guess, based on where you are located geographically, quite a bit how these DERs interact for sure. It's just, it seems to me that maybe in certain areas you can, not that you have to allocate, but you could possibly clarify that some of those areas see more export. So the investments are for the accommodation as compared to some of the areas that are load heavy, and therefore they're really not going to accommodate DER because there's no, the most popular DER being like ground mount solar. There's no way you can put a ground mount solar in a very heavily loaded city center.
So for the National Grid Plan, our analysis showed that for the most part, our system is load serving constrained. So the greater constraint was accommodating beneficial electrification in the forecast rather than DER hosting capacity constrained. There are certainly areas of our system, right, that are more hosting capacity constrained than others. But the general theme for the ESMP investments, particularly when we're looking at the aggressive load growth to support beneficial electrification, and also specifically focusing on the substation level, not getting down to, you know, individual site specific location for a specific DER or even load customer. All of the investments the network investments that we are proposing in our ESMP are driven by the need to increase load serving capacity, and hosting capacity is a secondary benefit.
I see. So in areas where there could be capacity increase, you wouldn't necessarily say that it is for accommodating DER, and the ESMPs are therefore not really thinking through the accommodation of DER at this point. Do you expect that to simply be reactive then in areas that will see DER capacity growth?
Emily, you want to go? Emily, you're muted. Otherwise, I can jump in quickly from Eversource's side. And Lavelle, yeah, you just came on camera as well. No, as Emily said, with Eversource as well, a majority of the projects is load driven. And we have about 800 megawatts of step loads. That's new business additions alone. Forget electrification, that's just load growth. New buildings being put up in the Metro Boston area. So, and to your question, if the ESMPs consider that beneficial crosslink, yes. But I don't know who said it. A substation in downtown Boston isn't going to enable hosting capacity. Nobody's deploying 200 megawatts worth of ground-mounted solar in downtown Boston. So we're just geographically so far apart on that. But the ESMPs do include proposals for new substation capacity that is specifically targeted at DG interconnection. And I don't remember the national grid numbers. Emily will have to speak to that, but I think on ours there's 7 groups. And I don't know the actual incremental numbers, but if I look at this here, let me do the math quickly again. It's another close to half a gigawatt of incremental solar capacity that's in there. That's just for the solar targeted ones. And then you have a lot of other projects, that's another gigawatt from the earlier discussion, that are not specifically solar targeted, that have joint benefits.
Right.
So, yes,
I have read through some of the upgrades that Eversource has proposed, and I understand the areas. With National Grid, though, the upgrades that I have reviewed, they do seem like there's no distinction between load versus hosting capacity for DER, and that's, I think, from what Emily's saying, load capacity for DER wasn't a big factor in the ESMPs, not this round of the ESMPs, if I understand it right.
So because the load growth in our forecast far outpaces the DER growth, DER, it's not that it wasn't a big factor, it's that it wasn't the primary driver. And that is something that we're looking to articulate more clearly as we're revising the plan before filing with the department, is the relationship between the enabled load serving capacity and hosting capacity in response to a lot of the great feedback we've gotten in forums like these from the GMAC.
All right. If you don't mind, MK, I'm going to bounce over your second question and give Russ a moment and try to move around amongst these different stakeholders to make sure we have a good representation. Russ, you've asked a number of questions. I'm thinking maybe I'll let you prioritize which one you want to ask first.
I'm going to go to Samer. I thought his was the most exciting part of the presentation today so far around grid services. So thank you for sharing that. One question I have is how you potentially value DER that's providing grid services. A lot of times DER has been considered as a deferral solution where it gets awarded a value equal to essentially the cost of funds of a capital improvement deferral, rather than actually a substitute for the capacity that it might actually be providing, and not just for a short period of time, but for a long period of time. How do we engage with National Grid or the other utilities to the degree that they're discussing a grid services framework or platform to discuss how to value DER assets? And also, since you mentioned Connected Solutions, which has I would say a healthy compensation scheme for behind the meter batteries discharging during peak periods, how would you evaluate the value of front of the meter batteries that can perform that same service during those same hours? And how would you suggest compensating those front of the meter batteries for that grid service? Thank you. I know there was a lot in there. Break it down, take it in any order you want.
See, my colleague John came on camera, so I'm going to defer to him.
Okay.
I'll be short. I don't want to steal Samer's thunder because I agree his was the favorite part of the presentation too. But I think, I mean, a couple of sort of short answers for you, Russ. I think the question about front of the meter battery value, like the short answer is yes, because I saw your question of like, can they provide those services in the same way that behind the meter batteries are compensated through connected solutions? There is value there. I think what we were sort of outlining in terms of your question around how do we engage is through that grid services study. So I think what we really want to make sure that we're doing is we're engaging with stakeholders, we're working across the other utilities, we're working with Mass CEC so that we have a common framework of how do these different assets provide value to the distribution grid, and then we can use that to figure out how to actually, go forward with the grid services compensation fund and find actual opportunities for non-wires alternatives. So I don't know if that answers it, but I think the how is like engaging with us through the course of that study.
Well, I guess I missed my invitation. So Samer, if you can send it back out, that would be great. I would be happy to engage. And the other thing I would ask is you might want to note to Ian Springsteel that front of the meter batteries do provide value when they discharge during peak periods, and that value should be compensated in some form or another, potentially included in the wholesale distribution tariff, if not through some other mechanism, given that I think we all agree there is significant value that they're providing during those hours, which is not for the distribution grid and is currently going uncompensated. So that's my final word. Thank you.
Thank you, Russ. Let me bounce down to, give me just a moment. I'm gonna have a few other folks chime in, and then Russ and MK, I'm gonna come back to you folks. Let's go back to Claire. Claire, I think this is just a clarification. I forgot who was presenting, but you're talking about the 2030 goal being 20 gigawatts of PV. Was that were you looking for someone to clarify? Sorry.
So that's 20 gigawatts of PV by 2030. So part of it was the expectation by the utilities that all the projects in the SIPs queues are going to build, which is highly optimistic. And what happens if 20% of them, whatever, don't? And if you're betting on that, then that I think limits your opportunities for building out the rest anywhere else. And I think because of the climate in Massachusetts, a lot of the big developers are not pursuing big projects. And it's, I think it's going to be more and more difficult, especially with the high capital costs now. Who knows what's going to happen with the smart incentive and who's actually eligible for them. So there are a number of complications, I think, in this forecasting. And I think that there's also the net metering issues that get added in. So that's just, I don't think it's as simplistic as saying that the SIPs projects are all going to get counted. I think that the utilities need to take into account that there's got to be some other mechanisms for encouraging PV development, not just waiting for developers to come up and say, this is where we've decided to work. And especially out here in Western Mass, we're getting a lot of pushback for cutting down trees. And that's going to be a big issue if you want to put big projects out in wooded, forested areas out here. Clearly, they're not going in downtown Boston, but Western Massachusetts is not as favorable as it has been in the past. I'll leave it at that. Oh, and I did want to add in on jump on Russ in that grid services. I think that's very interesting because basically energy efficiency and behind the meter solar is not compensated. nearly as much as it should be as a capacity building endeavor at the distribution level. Thanks.
Thanks, Claire. Those are good perspectives. I know there was those weren't necessarily pointed questions, but curious if any utilities had any remarks. And if not, we'll move on to other questions.
I want to comment about the 10 gigawatt by 2030 a little bit, because we look at the upstream scenario in the state 2050 roadmap, as well as the newly released CECP. All the scenarios seem to be proposed something between 5 to 8 gigawatt range across the state, like statewide. So I'm not quite sure about the 10 gigawatt or 20 gigawatt of by 2030 goal.
And we would second that. Some clarification on those numbers would be great.
Claire, would you be so kind?
So I think that the 20 gigawatts is total. So if we're at 3.5, 4 right now, approximately, then that's adding 6. It's 6.5. So that may be where the discrepancy lies.
Sorry, so the number is 10 gigawatts by 2030 that was mentioned, right? And from our perspective, the known plans by the state don't come nearly close to that number. So where is the 10 gigawatts coming from?
So I don't have a, this has been in discussions with other groups about what the 2030 climate plan passed in March of 22, I think, encompassed. So if I'm wrong, please excuse me, but there's still a gap between what the 2030 plan enacted and what the ESMPs are anticipating that they will interconnect by 2030.
So I think that would be an interesting discussion. We don't have to do this here.
No.
This could be something we can take offline, but we're going off the last published plans, not ongoing discussions. And if there are such ongoing discussions that would ramp up the projected solar significantly, at least I know my forecasting group is not involved in it. And given by Rain's question, I'm gathering National Grid's not involved either. So I would highly recommend to involve the EDCs in those discussions to make sure that we can capture that information and can adequately plan for it. Because if we're hearing it here for the first time, that means we're not in those discussions.
I understand. Thank you very much.
Thank you, Claire, and thank you, everyone. I'm going to bounce down to Doug Pope's question regarding the ADMS and DERMS platforms that are contemplated, maybe more specifically the planning features and their any plans to move towards AI. You know what, Doug, if you'd be so kind, let you iterate your question. Oh, Doug, are you still on the phone?
Yeah, no, yes. I suppose my question is, you have a lot of historic data, and planning is driven by data, particularly today. And my question is, do your planning models use the data that you already have in place for forecasting on a more expedited basis, your system planning modeling? And will you be, by using the traditional neural network type of concept, and will you be moving toward a modeling closer to using AI to help speed up this whole process? I mean, you have your PSCAD models, you have a lot of your existing data, you've got a tremendous amount of data. And are you able to aggregate that data into a predictive planning model that isn't hand done, that's using sort of using a historical base?
Yeah, so I'm going to jump in here quickly because we do have 2 projects, right, ongoing. And Russ, I answered to Russ's question earlier. I answered this on the interconnection automation, and we are working on doing some interconnection automation that would automate good portions of these processes and hopefully speed up the interconnection process. To the question, is AI going to replace the system planning process and do this for us? No, because right now, A, that's not reliable enough, and B, you still need human judgment in the loop to do this. I don't think anybody here is going to agree that a computer can do the full impact study and take responsibility for operating a safe and reliable system without a human in the loop.
Oh no, I was never implying that.
Good.
Yeah, I was, but the humans can use the tool that they input.
Yes, and there is, as I said, there is a project on the way, on at least on our side, to automate certain amounts of those steps. Is everything going to be able to automate? No, but we do hope to get significant improvements on the interconnection times out of this.
Thank you.
Perfect. And then let's bounce down to Brian's question. Brian, I'll let you iterate your question, but it looks like you're asking if AMI and DERMS platforms, what synergies can they share to avoid duplication, perhaps of costs or features?
I think,
yeah, it seems, I was just going to say, it seems that there's some of those features that would be in a DERMS can be had by or are had by AMI or could be had by AMI if they're set up correctly. And I understand the integration at the back end might be more challenging because the operations departments don't typically talk to the billing departments, but want to make sure that we're not missing out on an opportunity to leverage a technology that's also getting put out there.
And the short version is, Brian, yes. The way we think about it is there's a meter managed data management system that's collecting data, and it sends it to ADMS, the main controls of our system. And that will then talk to other technologies like Flizzr or DERMS to help us find and locate where we need to dispatch the load. So short version is we believe that we're going to have this kind of data sharing platform, and that ADMS, DERMS, and AMI will talk through that platform. So each one is aware of what they're doing. By theory, kind of the master control comes from the ADMS, but there is that kind of data bus where all of this information gets passed on between the systems.
And I guess I was also, that's good to hear. And I'm also curious, I'm pretty sure many AMI vendors are offering some sort of DER specific services as well. That might be, like simple communications channels that can be used to avoid having to build out communications to all the DER themselves, and just wondering if that has been looked at, reviewed, or being considered.
So we do utilize some of the kind of the mesh that's going to happen from the data transfer through AMI. But at the end of the day, if you read our grid mod plan, we actually developed a more kind of strategic plan, because it's not just DERMS, DER, it's also the capacitors, the reclosers, the Flizzr, the VVO, all of that communication. So we put out our entire plan for communications. You'll find it in our grid mod filing. But you can't really utilize the entirety of the data communications platform in AMI, really. There's just more capacity than you need, or there's, sorry, more need than you have capacity. But we did present that our case for what we want to do with our data, with our communications plan. It's in grid.
Okay, thank you.
Thank you, Brian. Thank you, team. All right, I'm going to bounce back up to MK's last question, and I know this was at least answered in one of the slides, and that is, these DERMS platforms, are they being contemplated for distribution grid services as well as, say, transmission market participation? MK, if you're on the line, if you could iterate your question, or if I got it right.
That is right. I think it was just after I asked the question that there was a plan that showed some of the years that you expect some of the features to be available. If you could flash that on the screen one more time.
MK, which slide were you referring to? Apologize.
It was for Sammer's presentation. I think he has like a timeline of what he thinks is going to be the implementation timeline for
that. So the short version is, and I think she's referring to slide 56. So MK, the short version of this, there is the distribution system grid services and their need, and that's our market platform. And then there is some of the transmission system needs, and that's from FERC 2222 compliance. We're going to have to communicate with ISO and coordinate some of this together. We call that ESO-ISO coordination. But the short version is we have a market platform and grid services, and so does the ISO.
Those purple diamonds are where we should expect it to be fully functional, each of those services?
Yes, that's where you get the full functionality. Now remember, we're doing Agile, so we're going to start trying to introduce some functionality early on.
Okay, thanks.
Perfect. Thanks, you two. Russ, I'm going to come back to some of your questions. I was going to just run down the list unless you want to prioritize them, but the next one on this list is, what if, pending interconnection bottlenecks, what if DERs hit their 2030 targets sooner? More specifically, solar storage.
Yeah, and this was actually, I wrote this down when Lavelle was presenting, and he noted that Eversource was going to stay ahead of the hosting capacity requirement given its plans, and I respect that and I'm grateful. My concern is that solar has consistently overachieved in terms of its deployment. I think, again, the only thing that's a critical constraint is the interconnection process. So hopefully the utilities are not holding back solar to keep it in line with hosting capacity availability. I think the notion here is that, both here in Massachusetts, if not nationally and globally, we have reached those goals early, if allowed to proceed at the pace that we desire. And so I'm wondering, what are the backup plans or contingency plans for DER that continues to outpace the capacity that's being developed as either part of this plan or through CIP processes? Are we going to be back to solar is paying for the upgrades to the grid that eventually will come? Or is there some way in the ESMP plans where additional capacity can be constructed and the cost not completely allocated onto the back of DER developers? Thank you.
Thanks for the question.
Go ahead, Lavelle.
Russ, no, I appreciate the question. And your question was thrown in there. We are definitely never will, never have contemplated holding back solar. We do take our obligation to interconnect customers seriously. And I know there are historical reasons why some of this has slowed down. And among them, the queue stagnation, free rider, cost causation principle. And we have said in many, many forums that the way to overcome this is the SIPs, group studies on cost allocation. And you have seen that we've been successful in getting one approved in Massachusetts, in Marion Fairhaven. We have 5 pending. We're hoping that they would be approved. That puts us at another gigawatt of hosting capacity level. So we're not standing still. We've said in this session that we have proposed another 7 SIPs, 5 in Western Massachusetts, 1 in the East, 1 in Metro West, 2 in Metro West actually. And this will provide another 500 megawatts of hosting capacity. But what we've made very clear in the SIPs is that going forward, the way to do this is more SIPs. We understand that we need to totally reinvent our planning process. When there was a 2075 docket -C was meant to be that integrated plan to proactively build our system for DER interconnection. That was subsumed under the ESMP, and we took the opportunity, as I mentioned before, and I'm sorry if I repeat myself, in Chapter 9 to lay out the process. We would proactively, using our knowledge of land use, using the state's database, using the grid twin tool, we would look at where the developable land is, look at the historical trends, include the policy directives, and forecast or project not to use a forecast word, but project solar development across the state and target those areas proactively to build substations. So switching from a paradigm of we're seeing constraints, let's go build a station to address those constraints. The paradigm is now we project that this area is a hotbed for solar. We project that in order to meet the state's goals, we need to enable that solar. So let's go build the infrastructure and we will connect the solar and release the bottleneck. So again, that's our method going forward. We have proposed it in the ESMP. We are looking for approval from the DPU. We are looking for buy-in from stakeholders. But even if that doesn't take, doing SIPs, doing group studies, going forward, that's how we would address the key issue of constraint was. We would group everything and study the heck out of them as groups.
What you say warms my heart, Lavelle. I'm sorry, Gerhard, just a quick response to Lavelle. So what you said, I'm grateful for that and for the adoption of the SIP approach going forward. I'll also note that we've had a project in a SIP group study for 5 years, and that pace for interconnection is woefully slow. And so I hope that you also request in your ESMP request to add more SIP group studies, that you have pre-approval of your SIP formula or the cost allocation methodology that you tend to use based on the pilot SIP projects that are still pending, so that they can be done expeditiously and take no longer than a group study without a SIP today, and hopefully potentially even faster. But so just note that we're very concerned that even though there's the beneficiary pays principle is integral to what we call the SIP process, that's really what we're talking about, and being able to allocate those costs more, I guess, more fairly across the folks that benefit from the upgrades. The timeliness is it's also critical. And again, our fear here is that we're never going to see this interconnection queue the problems resolved in the near future. I'm not hearing a ton of investments. Excuse me, Gerhard, but there's not a ton of investments towards making that process faster and reaching key decision points more quickly, so that we can actually get things built. The utilities hold the key to that. And so I'm hoping that, and again, this is my third time probably saying it, that you are investing in that also. Thank you.
No, it bears repeating, and I appreciate it, Russ. And just for the record, all 3 EDCs, this is something that we've been discussing. We will certainly put proposals before the DPU in the interim for the next ESMP. We would have an improved cost allocation methodology that we're proposing. But one of the things that we do recognize is that, to your point, your project that has been caught up in the process, it's not all technical. There's a lot of procedural, adjudicatory related issues why it's been held up. A decision that's forthcoming has not been given yet. And so we are hoping, we are discussing with stakeholders a way that we can streamline the process from a regulatory standpoint and get the approvals faster. I know I feel your pain. I understand what you're saying, but it's something that that we're working on. Hopefully we can get your passion to help push this along.
I hope for happy holiday
One
gifts.
quick point. Quick point to add what Lavelle was saying, and to bring this back to the ESMP issues. So as Lavelle said earlier, physical construction can only be done so fast. But to Doug's concern, the ESMP is not it's very dynamic. We are going to continue to upgrade our or update our planning process as well as forecasts every year. So this is not just a one-time plan and then we don't do anything with it for 5 years. We're going to continue to update our planning and forecasts based on the load and the DER that we see. So I just want to let people know that this is not just a one-time thing.
Thank you.
And I did want to add one quick comment, Doug, right? In addition to capacity build out with all the constraints, and to Lavelle's point, right? Procedure, and I disagree with the statement that we hold all the keys. You can also go talk to the state regulator and policymakers about speeding up these processes, and please do so. There's also other initiatives, right? So Samer talked about flexible interconnection. We just filed the operational tariff that would allow those sites to interconnect in constrained systems. If they're, for example, co-sited with storage, they can use that to minimize their impact or need for hosting capacity. So there's a lot of other things we can do to stretch the existing hosting capacity further. It's not just new substations, but that is an integral part. And you can't stretch anything if there's nothing left, right?
Thanks, Doctor.
Thank you. Thank you, Russ, and thank you, everyone. That takes us through most of our questions, with the exception of, Russ, you had a question about platforms. I want to apologize that we're at time now, but wanted to thank all of the participants and everybody who asked these, what I thought were really great questions, and thank you for being respectful. And maybe with that, I'll pass it back to Michael.
Thank you, Sam. Yes, I agree. Great discussion today. So thank you, everyone, for participating. I did not have anything else left for the meeting here, and like you said, we are right at time. So I think we'll close it for today. Look forward to the next quarterly meeting that we'll have in March. And thank you all very much for the time today.
Thank you, everyone.
Yeah, I think that'd be steps.